Hi, welcome to this second part of the chapter Thinking in Objects. So, in this chapter, we started with looking at the concept of two-string method, which is very helpful. And we should be writing two-string method in all our class so that if needed, if the user wants to look into the object for the corresponding class, then the user should invoke two-string method. We also looked at more details in the UML. We learned like how to distinguish the accessibility. If a data member is public, then we'll put a plus before that, and if it is private, we'll put a minus before that, and the same notion would be applied to the methods as well. We also looked at static data members and static methods. How do we represent them in the UML? And then we understood the difference between the public package private and private visibility. And then we were on this topic. We looked at this concept that even if you create an object and for that object you declare a class, then you can also create an array for that class. And we have learned about arrays, but most of the programs that we wrote till now, we based on the arrays of primitive data types or arrays of type string. So string array is an array of reference values, but again a string is a class that we did not define. So right here what we will be doing now, we will make use of the circle class that we have defined and create an array, a circle array. Okay, so I explained this thing to you in the last lecture. So what I'll do right now is I will do a demo, and let's try to see how will it work out. So let me use the class that I've already defined. Circle class we have looked at, and we have a very decent understanding of the different data members and the different methods that go inside it. So two-string method we defined in the last class. So right here we have the test circle class. In the test circle class, I am creating two objects, my circle and your circle. And my circle is the object which is created by invoking the noArg constructor, whereas your circle, for your circle we are passing on the radius value, which is 10. So let me run this one more time, because right here on the statement number 5 and statement number 6 we are invoking two-string method. And there are two ways to invoke two-string method. Either you can explicitly say dot toString, or the other way is that don't mention toString. If you have just the name of the object, anyway it will invoke the toString method. So on line number 5 I'm explicitly calling toString method, whereas in line number 6 I'm not doing it, but anyway since I have the name of the object, it will call the toString method. So let's run it. Java C test circle dot java, and then we'll say java test circle. Alright, so yeah, now we are getting the information about this circle object, and that's how we wrote two-string method. We are returning the radius and the area, and this is coming from the two-string method that you have written. Good. So let's do this array part. Now I need to declare circle array. Circle array, it would be my array, and its type should be circle class. So I will say circle and then square brackets, because that's how you distinguish an array from the other data types. And here I should say new circle, circle, and I'll put some values. Let me create an array of size 5. Okay, fine. Now let's start experimenting from here. What I will be doing, let me print this thing itself, and we'll try to see what is that, right? What kind of value we will get. So I'm just printing this array, alright, which is a reference. So if you go back to the lecture here, then what do we have in circle array? Circle array will be storing a reference, and this is a reference to an array, and each element in the array will be again a reference to the circle objects if you create that. I did not assign anything to the individual circle array elements. So right now I should be able to just see a reference value. So let's look at that. I'll go back, saved it. Now JavaScript. Alright, so you can see, you know what, this is a reference value, so it's a reference to an array. Okay, now let's go a step further and try to see that once you have done the array declaration in line number 7, what will happen if I print individual values from there. Is equal to 0, I is less than circle array dot length I plus plus. So here I want to see what is there by default in my array elements. So how will I do? I need to provide the index value. Alright, so right now I'm interested in finding out these values, like what do I have in circle array and square bracket 0, circle array square bracket 1, and circle array. So here the size was 10, but in my example size is 5. Okay, so again you should see some reference values, but those reference values are interesting. So let's see what are we getting. Null, 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 null. So all these 5 values are null. So you should understand this concept, like why did I get null, right? So if you remember, in arrays, when you create an array, then the elements of the array are initialized to default. Okay, so what is the default here? Default value of circle array is null. Why? That is for the reason that because circle array will hold reference. Alright, so look at the type of circle array. Circle array is an array of type circle class. And what is circle? Circle is a class. So the variable that you'll create for a circle class like this is a reference variable. My circle is reference, your circle is a reference, and these are the reference variable which will be holding the address of the objects that you create. So in this case, if you are paying attention, then from line number 7 till line number 11, we did not initialize, we did not put any reference inside the circle array. We just created it and we are printing it out. So although the circle array should be storing the references, but these reference values are null because we haven't assigned anything for that. Okay, so can I assign the reference? Why not? So let's do this thing. Right here, I can say circle array 0 equals my circle. Okay, so let me put the reference of the first object that I created as my first element in circle array, and the same I can do with the second element also. So right here, let me store the reference of the second object that I have created. Alright, and now I should print statement right here so that we can understand the output. I will say from the circle array. So I mean to say that these values that you see are now coming from circle array. Okay, so let's run this thing. We'll see Java C test circle dot Java test circle. Alright, now you should see the difference, right? Now I'm not getting null values for all the 5 elements. The size of circle array is 5. Earlier I was getting null values for all the 5 elements that I have in circle array. But right now, since I have done this initialization in line number 9 and line number 10 respectively, I am putting the reference of my circle and your circle in these 2 elements. So now these values are different. I did not change anything in the for loop, because using the for loop, just calling these, I'm calling toString method. Alright, so yeah, that's what I'm doing. I'm just calling toString method, right, on each element of the circle array. So I get the real values for the first circle object, that is my circle, and the second circle object, which is your circle, because that's what I did in line number 9 and 10. Okay, good. Now let me do one more thing. Now I don't want to initialize with these 2 things. You have just seen the result. I can do something different. Alright, and here let me do this. What should I say? I should say circle array I equals new circle and I plus 1. So what am I trying to do? Well, the very first element, or the very first element that I want to assign to the circle array would be a reference to a circle object which will be created right here. On the right hand side, I'm creating that object, and the first object that I will be creating will be having the radius of I is equal to 0, 0 plus 1. Okay, so the first object, a circle object, will be of radius 1, the second will be of radius 2, 3, 4 and 5. So from this for loop now, I am not printing anything. Instead, I am creating, let me delete it because this is meaningless now where I am changing this code. Alright, so now I am initializing, I am creating circle objects for different elements of the circle array and assigning that. Okay, and after that I should print it out. So here I should write system.out.println. Alright, yeah, this should be fine. And although it's not going to make much difference, but let me take it out here and I will put this statement after the initialization. I hope this works. Okay, it did not complain. So what are we getting? Well, see exactly what I said. We are printing from the array and radius 1, 2, 3, 4, 5. Alright, because that's how you're creating. Here the circle, the radius was 1, then 2, 3, 4 and 5. This for loop will kick in, and that results in creation of 5 objects with the radius varying as 1, 2, 3, 4 and 5. So a lot of interesting thing you can do, rather than keeping the radius fixed on the I You can also call any random method, or you can randomly generate these radius and hence create the object. So I like this example and it was interesting. I hope that it explains the concept that we can create an array of object, and here we are dealing with the array of circle class. Good. So I think I'm done with this slide. Let's move on. Now this is an interesting concept that we are about to learn. This has to do with the objects type. So certain class of objects and classes would be called immutable if we cannot change the objects that we create using those classes. Now you should understand that we will be making all our data members private. That's how we should be doing it. Now if you create an object, and for that object you have declared a class in such a way that the class does not have any public data member, and the class also does not have any setter. Okay, so let's look at this example that we have. Now if we modify our circle class in such a way that we are keeping radius as private, we have done that in our example as well, but probably we had a setter there. If you remove all the setter methods from there, or all mutators from the class definition, then there won't be any way you could change the object that you create. Okay, so these classes and the objects which are such that you cannot change their data fields once they are created, then they are called immutable. Alright, so now there's an interesting thing that goes in the definition of immutable objects and classes. We'll try to understand that. So here it's an immutable class because we do not have a setter method right here. Okay, we have getter only, and radius is the only data member which is private. We cannot change that from outside the class. So whenever we are saying that we can change or not change, then that means changing from outside the class. Anyway, from the class itself you can always change that. So from the class like test circle you cannot change the radius value. From circle class, yes, you can change if you want to. Radius is private, we cannot change that without a setter method. Now a class with all private data fields and without muters is not necessarily immutable. This is the important point. Okay, so from what I have explained to you till now, and probably what you could also think, that an object would be called immutable if it is derived or it's been defined from a class where we do not have any we do not have any public or package private data fields. All the data fields are private and there's no setter. So that's what you have learned, and that's what I explained to you till now. But there's another thing that we should understand, right? For that I'll give you an example. So probably with that example you will understand what I'm trying to say. So one more time, let's understand this statement. Let's understand what this statement is saying, and then I'll use an example to explain that. A class with all private data fields and without mutator is not necessarily immutable. So there's another thing which may make it mutable. Right, so what is that another thing which can make it mutable? Let's try to understand that from a different example. Okay, so why should class be immutable? Let's try to understand this thing, and I'll return back. After the example, I'll take you back to this slide and we'll understand this thing even better. So what class is immutable? So the conditions. First, it should mark all the data fields private. You got it straight, I think. We don't need to explain any further. It must have all the data fields as private. First point. Second point, it should not have any mutator method. Okay, mutator means setter. Setter and mutator, these are the same methods which are public, and these methods can change the data fields if you call these methods from outside the class. Okay. Now this third point is very important, and that's where we'll have little difficulty understanding that, so please pay attention. Now it should not provide any accessor method that would return a reference to a mutable data field object. Okay, so this is a little complex to understand. It should an immutable object should have all the data fields private. It should not have any mutator method, and at the same time it should not have any accessor method. That means it should not have any getter method which could return a reference to an object or which has a mutable data field. So let's understand that. Good. So for that, pay attention to this example that I have here. Okay, so let's look at this one by one. Student class. Alright, let's look at student. How are we defining a student? So the student class is public. It has two data members. ID could be your SBU ID, could be any other ID. Okay, the purpose of the ID field is to identify the student, and it's an integer field. And as we should have done, we are declaring that as private data field encapsulation. There's another field we have for the student, which is birth date. Alright, and birth date is also private. Now, how is this birth date defined for every person? If we have birth date, then the birth date should have three fields in there: the year, month, and day. Okay, right? So, well, how do we define that? This looks like a class name. Private birth date looks like a class name because it's capital B. So all the classes that you create, they should have they should start with the capital letter. That's the convention that we have in Java. All classes capital letters. So public class student, S is capital. So when you say private birth date, B is capital, that means birth date is a class. Okay, and using that class, you're creating and defining the object which is birth date for a particular student. Now, don't worry about birth date, because you know on the right hand side we are defining a class called birth date class. Alright, so this object that you have is of the type this class which we have in the right box. I'll come to this class later. Let's try to understand the student class first. Now you have a constructor for student class. You are passing on 4 arguments to this constructor. The first is an ID, which we are considering as SSN in this example. Then you have these three fields which we will be using for the birth date: the year when the student was born, the month, and the day when the student was born. So we need these three fields for our constructor. In the constructor, you are assigning these values which you get from user. Like ID becomes SSN. For birth date, you are creating this object by calling this class, by calling the constructor of this class. Okay, this constructor right here. When you say new birth date, year, month, day, this specific constructor would be called N. You have couple of getters, and these getters are for ID and birth date. You're perfectly fine. The first two conditions which we had set forward for immutable class are satisfied. ID is private, birth date is private. Great. You have a constructor, two getters. You don't have any setter, right? So we are good. By first two definitions, we are good. Great. Alright, now let's look at this birth date class. What do we have in this class? Three data members: year, month, and day, integers. That's how we are defining, and all these three are private. Great. Then you have a constructor for birth date, which will accept year, month, and day information, and it will create the object when you invoke with this method with the new. Alright, so right here we are doing it, right here we are calling it. So that's how you will create an object of type birth date class. And right here you have a setter method. If you want to change the year of the birth of the student, you can do that. So as the setter should be, it's a public member, and you have no return type. Setters don't have return types usually. Public void set year. So whatever you provide, the date of the year field of date birth date would be changed to the value that you provide. Then you have a get year method. Okay, great. So we have defined these two classes which we will be using to create a state and a student object. So let's do this thing now, the test class. So in the test class you have just one method, as we usually do. We have a main method. In the main method you're creating a student object using the student class right here, and you're calling a constructor because you have new. Then with new you say student, you provide SSN number for this student, you provide the year of birth which is 1998, and this student is born on 1st of Jan. Good. Now the interesting part is that when you create this student object, right, which we did right here, now we have a method in the student class which is marked here in red. Alright, what is this method doing? This method is returning a reference. What is birth date? Birth date is the class type, right? Birth date is a class here. So when you say public birth date get birth date, that means you are returning the birth date reference. Okay, why? Because look at the return type, it is birth date. Birth date is the name of the class. So you're returning the reference. And what field you're returning? You are returning birth date. So birth date is a reference data type. So the getter method that you have, which is get birth date, it is returning the reference to the birth date. Okay, so now this student class that you have, it has a method which is returning a reference to the data field. Okay, so now what can happen? So what we are doing, we are using this fact and creating a date reference which is of type birth date class. And how do we do that? You have to use the student object and you call student.getBirthDate. So the birth date object, this will be that reference will be copied into date. Now since this birth date class has a setter in it which is year, you can exploit this loophole, right? The birth date object has a method in it which is setter. So what we are doing here, anyway, we have copied the reference of the birth date field for this student object in the date reference variable. Now what we can do, we can invoke setYear method on this. We have a setter for birth date class. We don't have setter for student, but we do have a setter for birth date object. Alright, so that's a loophole. So using that you can change the year of the birth for the student. Alright, and what will happen if you try to print the information of the student now, then the year would be printed as 2050. Okay, so that's the catch. The catch is that if you have an accessor method like the way we have here, which is returning a reference to a data field which has a setter. So here what we are returning the birth date, which is a reference. So we have an accessor method in student which is returning the reference value, and that reference value corresponds to a class that has a setter method. Okay, so that was the loophole which we exploited, and we were able to change the birth date which was private. Okay, so that is an additional condition which we should have in case of mutable object. We should not have any method like this. So this method right here is making the student class mutable. It's no more immutable, right? It would be immutable if you don't have this field, this method right here. The presence of this method is making it mutable. All right, so I hope you understood this thing, but well, it's challenging. So I expect some questions from you when I'll be in my office hours, or probably when we are on Zoom. So this last point again, right? So the stat point has been explained using this example right here. Okay, so all these reds that you have relates to the third condition that we have. A class is immutable if it marks all its data fields private and provides no mutator method. So here we don't have any mutator method, but we should also not have, it should provide no accessor method that would return a reference to a mutable data field object. So here, this data field object that you have, which is birth date, is mutable. Why mutable? Because in birth date you have a setter, right? You have a setter. So birth date is mutable data field, and its reference is being returned by this method, which is get birth date, and that's messing up the system. Okay, so yeah, please keep this in mind, and I like this concept. It's very interesting. Great. Now what do we have here? Well, scope of variables, right? So probably if we looked at it, we looked at local versus the instance data fields, and we looked at that thing, and we by now know that for local variables you should initialize local variables in your method, and if you don't initialize local variables you get compiler errors. Whereas for instance data members, you don't need to always initialize them. They sometimes get default values. Now let's see, do we have any additional information into that? So data field variables, which means your data members, can be declared anyway inside the class. Okay, so till now I have been, I had just one simple class example, which was of circle. So we declared a radius at the top, but you can take that declaration of the radius even at the bottom, does not matter. So once the radius has been defined or declared in your class, it has the scope throughout the class. You can access that data member from anywhere inside your class. So data field variables can be declared anywhere inside a class, and the scope of the instance as well as static variable is inside the entire class, and they are initialized with default values. So these are a few things we have to learn about data field variables, like how they are different from the local variable. How about local variable? Now the local variable is confined to the code block, I will say, where we are declaring it. Okay, so the scope of a local variable starts from its declaration and continues till the end of the block that contains the variable. So it's very interesting in case of for loop, when you have written a for loop with some I, for int I is equal to 0, I is less than 10, I plus plus, and then this I is only accessible in the code block that you create. If you try to print the I outside, then you might get a compiler error if I is not already defined outside the block. Alright, so that's about the difference between the data fields and the data field variable and local variable. And local variable must be initialized explicitly before it can be used. If you don't do that, then that's a compiler error. Great. Now let's move to another interesting keyword, which is called this. Now, what is the purpose of keyword this? Well, it is very handy. It is very handy, and if you look at some implementations of object, then you will see that this keyword is used very often. Now, when do we use this keyword? we'll be using this keyword at two places. At one place when we will be referring to a reference, and the other case would be when we call the constructor inside the class. Okay, so well, for this also I think I should do a demo, and that demo will explain what I am doing. Alright, so anyway, let me see if I could explain few things from my lecture slides before I go to the demo. Now what happens is that sometimes you want to refer to the object that is invoking the data, invoking the class members. So if you want to refer to the object which is invoking methods of a class, then you'll have to use this keyword for that reference. Okay, so common use of this keyword is to reference a class hidden data fields. I'll explain to you what is a hidden data field, and for that I'll be using a demo. So I'll use the example as well as the demo to tell you what is hidden and when can the data field be hidden. And it is also used for invoking a constructor. So the next chapter would be on inheritance, and when we do inheritance, then you will see that we will be using this very often. So what happens usually when you have multiple constructor in a class, you might need to call one constructor from the other constructor. So these two constructors are in the same class, but say I have written two constructors. This is also something that I'll do in the demo. If I've written two constructors, I might call one constructor from the other constructor of the same class. And when you have to do that, then we use this keyword to call the other constructor. Alright, so that's the purpose of this, but it might be a little difficult for you to understand what I am explaining, but hopefully when I do the demo, it will explain. Alright, let's try to understand that from the example that I have here. Now, let's see what do we have. On the left block, pay attention to what I have on the left. You have a class which is called foo. It's a public class. I'm calling that foo. And right here we have two data members. The first is private, and it's integer I, and I is being declared as 5, initialized to 5. Second data member that you have is private, but it is static. Its type is double, its name is k, and has been initialized to 0. Good. So this was straightforward, right? Not much to explain. One is instance data member, the other one is static. So this is class and this is instance, because if you have static, that means it's class. Now let's look at this set I. What are we doing in this set I? Well, in this set I, look at how we are defining set I. So we want to set the value of I. It is a setter method. We want to change the value of I. Right now I is 5. So by default it will be 5. But if you want to change the I to some other value, you'll be calling set I. Now in the set I, look at this. The argument which is being passed on is also an I. Alright, so in this method that you have, which is set I, you will initialize the value of I that you're getting from user to this field I. Okay, so there are two I's. In this set I method, we are referring to two variables with the same name. The one variable which is the argument right here, okay, inside the parenthesis. The other I that you have is the data member, which the data member of the foo class, right? So there'll be places where you want to distinguish which variable I am referring to. Am I referring to the variable which is the argument of this set method, or I am referring to the I which is the data member of this class? So whenever you have to access the data member of this class means the foo class, so you will refer to that by using this keyword. Alright, so that's where this is handy. If I say I is equal to I, that will be interesting. I'm going to do that in my demo. I'll do I is equal to I, right? So something will happen, something interesting will happen if I don't say this dot I is equal to I. Ideally, I should say this dot I is equal to I. Why? If I say this dot I, then this is referring to the reference of the object which is invoking the set method. Alright, and what would be the impact? The impact would be that this dot I means the instance variable I. Its value should be set to the I right here. Alright, so that's where this and the keyword this is very handy. Great. Now how about the next method, which is set k? In set k, again, the value that is being passed on, the variable which we are using to reset or set the value of k is same, k and k, right? Now this k is being used to change the value of k right here. How do we distinguish the data member? It's not the data field, right? It's static field. It's the class data member. It's not the instance data member. It's the class data member. So we need to distinguish the k from k that we are getting in the parentheses. That's the argument. So how do we do that? Now this is slightly different, right? Why is this different? Because it's static, right? It's static, so we will not be using this. What we will use, we'll use the name of the class. Very important. So what we will do, we will say this k that I have, this k belongs to the class. Okay, so I should say foo.k is equal to k. Now we are good. Alright, fine. Let's look at the information that we have in the right block. What is it saying? It says that suppose that f1 and f2 are two objects of foo class. Now when you invoke, when you're saying f1 dot set I is equal to 10, f1 you created, f1 is of type class foo, so probably you have done something like you have said foo f1 is equal to new foo, right? So now f1 is an object, and how do you call this set I? You'll have to do f1 dot set I 10. You're trying to change the value of I, which is 5, to 10. So you'll call that as f1 dot set I 10. Now whenever you're saying f1 dot set I, then f1 is the reference that is invoking set I. Alright, so here when you say this dot I, then this right here is referring to f1. Why f1? Because f1 is invoking set I. Alright, so that's the interesting thing. The value that the keyword this refers to depends on the object that is invoking set I. So if you do f1 dot set I is equal to 10, then this would refer to f1. But if you invoke set I, which is set I 45, using the different object which is f2, then right here the keyword this will refer to f2, not f1. Why f2? Because f2 is invoking set I. Here f1 was invoking set I. So here this refers to f1. Here the same, and this refers to f2. So this will refer to whichever method is invoking it. Alright, interesting, very important. Okay, so yeah, please make sure that you understand this thing. Okay, great. Alright, so what I will do, I will come back to this last slide, because what I want to do in the demo is very much like what we have in the last slide. Alright, so let me delete this part. I'm not interested in arrays anymore. We saw that. Alright, so let's do this. Okay, good. So here, well, till now we have been using a different variable name for the constructor, but usually what we do, we keep the same name. Alright, so what we do, we usually keep the same name of the variable. So radius right here is the data field of the circle class, and in the constructor also we will not say new radius, we'll say radius. This is the convention, radius. Okay, good. So what I am doing, there's a constructor called radius, constructor called a circle, and this is an arg constructor. Alright, this is an argument constructor. Earlier I had new circle, a new radius. Let me change that to radius right now. We will be using radius only. We may not use new radius again, and you might find it little confusing, like why is this guy making my life tough? But that's how the things are. That's how we do in convention. We will call radius wherever you find it. Call radius. No new radius, no RAD, no R1, no. It's radius only. Alright, so I changed that. Let me see what will happen now. Okay, so in the test circle, I am creating two circles. My circle, for that I am calling the no arg constructor. For the second one, which is your circle, I am calling the arg constructor with the value 10. So this 10 should be copied in radius. Alright, good. Let's run this. Java C test circle dot Java, and Java test circle. Alright, wait a second, I think I'm still printing. Oh, I did not save my file right here. Alright, now see the interesting thing, what happened. My circle information is perfect because when you call my circle, that means you call the no arg constructor, and no arg constructor is setting the radius to 1. Back here, no arg constructor is setting the radius to 1. Good. But what went wrong in my second call? In the second call, I am calling the constructor with the radius value 10. What happened? Well, you know what? Problem is right here. Problem. Okay. Why is this problem? Because when you set radius is equal to radius, right here you are not referring to the radius data field. We are not referring to the data field radius right here. Okay, so how to fix it? So what is happening here, this radius variable that I have here, let me add this detail as well. Radius argument of constructor is hiding, this is a technical definition, hiding data field radius. Alright, so when you are right here in the constructor and you say radius, then the constructor is only looking at this radius that is being passed to the constructor, and this variable name is hiding and the data member radius. So how do we fix that? Well, refer to that, this dot radius. Alright, so when you say this dot radius, that means you are referring to radius on the line number 2. Okay, so the radius on line number 2, which is the data member of the circle class, is being initialized with the radius that you pass on. Okay, so that was hiding. We will revisit hiding in our coming chapters. We'll discuss this in detail, but it's important, right? For the timing it is important. Yeah, it fixed, right? So now we are able to fix this code. Alright, so I hope this helped you. So what do we do? Wherever we need radius, we use this. Radius is equal to this dot radius. And where's the area? Okay, right here you should say this dot radius multiplied by this dot radius. Okay, let me compile program one more time. Okay, great. Now that was about using this as reference, right? This and yeah. So here this keyword has been used as reference. Now let me try another thing, okay, which is this 1.0. What am I doing here? I'm calling the arg constructor. All right, so this might mess up with my counter, so I'll delete the counter. Let's not think about counter thing. The reason why I had counter earlier was to explain to you the concept of static thing, but I hope you got that static thing, so I'll delete. So I deleted that count thing because that might come in my way of explaining the importance of this. So right here in the constructor, if you pay attention what I'm doing, in circle class, right? Sorry, in the circle class I have two constructor, the no arg constructor and the arg constructor. Now what did I do here? So what I'm saying is that if the user is not giving me any radius, not providing me any radius information, then what I'll do, I will call my second constructor. Where is my second constructor? Right here. Okay, and how do I call the second constructor from my first constructor? By using this. All right, so when you use this with the parentheses, this is a method, right? This is a method because right now you have this and then you have parentheses. So from one constructor you can call another constructor by using this. So I am calling my second constructor and I am passing on the value 1.0. Okay, so this will do the same thing, but now I'm kind of connecting these two constructors. So don't worry, all these things we are going to discuss in detail in our next class. Okay, great. So it worked, right? So what was the purpose of doing this thing and making your life slightly more complicated? To explain to you the importance of the keyword this. All right, it can be used at two places. Right here we are using it so that you can refer to the data member. Otherwise, the radius argument that we were getting in the constructor was hiding our instance variable radius. All right, so that was one, and the other case we are using it as a constructor. All right, so let me take you now to the last slide that we have, which is very similar to what I did. Okay, yeah, good. So now in the slide also we are doing the same thing. Okay, in the first constructor, which has now become the second constructor, the sequence is different right here in the slide. I had that before the arg constructor, but doesn't make much of difference. All right, so the same thing, we have data private double radius, then you have this constructor, you're setting radius to the radius. So since you use this, so you're good. This must be explicitly used to reference the data field. Okay, yeah, so I hope that I explained these things to you and you can go over these details that I have in the slide. Thank you so much and take care.